Hey guys, this is John. This is a two-part video on stair building. In this video we're going to learn the math behind a set of stairs. The basic concept of a staircase is so that you can divide the step from one floor system to another in equal measurements so that it's comfortable as you walk between them. Let's briefly go over some of the components in this model and some of the general building terms that I'll be using. Here we have the framed walls that will receive the stair stringers, the floor joist already in place and the opening created. This basement is framed with a single bottom plate and a double top plate with studs and joists at 16 inches on center. There will be 3/4 inch tongue and groove subfloor applied to the top of the floor joist. Okay, let me explain a concept that might help understand the process of this math. Currently we have a one stair set of stairs. It's from the top of the floor sheeting to the top of the basement floor. There's one step. It's about 8 feet tall. If we didn't like that and wanted to divide it into 2 steps, we could divide that step right here in the middle, and there'd be one step that's 4 feet, another step that's 4 feet. Obviously this is the wrong way to build stairs, but the concept illustrates the process of deciding how many stairs will be needed to get from one floor to the other in a comfortable way. The code says that those steps can be no larger than 8 inches tall from top of step to top of step. So we'll need to divide the total distance from top of subfloor to top of basement floor in a way that'll be less than 8 inches. Well, let's measure what we have for height. For simplicity, we're going to assume that all of the floor finishes are the same. Let's say that there's going to be carpet at the top of the stairs and carpet at the bottom of the stairs. The math gets a little more complicated if you have different floor finishes, but we'll just keep it at carpet at the top and carpet at the bottom. From the top of subfloor straight down to the top of basement floor, we have 8 foot 10 and an eighth inches. As you can see, since we're going to be dividing the stair heights into increments less than a foot, we're going to want to read the tape so that it just says inches. So on a tape measure that would turn into 106 and an eighth inch total distance. You might be tempted to round to an even number of 106, but I would encourage to maintain accuracy to an eighth of an inch while doing stairs. And we'll find out why in a moment. There are construction calculators that will simplify the math for you, but I'll be using this basic calculator for this tutorial to show how simple it can be without one. First I'm going to take the eighth of an inch and convert it into decimal, and then add the 106 other inches. Now we have our total height in decimal form. Going back to my silly exaggeration, if we were to divide this one stair into 2 stairs, it looks like we would have just over 53 inches in stairs. That's much higher than our maximum of 8 inches. 3 stairs wouldn't quite get us there, or 4. Let's jump to 13. Oh, we are so close, just over 8 inches. 14 says close to 7.5, so that is right around where we want to be. We could go 15 or more and have it still satisfy the code, but we want to reduce the amount of stairs to the least amount possible. Okay, so at 14 stairs, we have this big decimal that we need to convert into something we can work with on a tape measure. On your tape measure, you'll find each inch is divided into 16 increments. On this chart, I have divided the 16 increments we have 1/16, 2/16, and so on. Over here are the common reduction names of those 16th inch increments, and over here are the decimal equivalent of those fractions. Our calculator says 0.5803 and so on. Here at 9/16, we're just under 0.5658, so just above 9/16, in between 9/16 and 10/16. We are closer to the 9/16, so that will be the one we want to choose. Remember, we're only needing to be as accurate as a 16th, but not any less accurate. If you think about having an error of 1/16 for all of the stairs, we have almost 16 stairs, so we would be almost an inch off of our measurement at the end. Okay, so we have 14 stairs. That will be 7 9/16 tall, which means that if I was to draw a line every 7 9/16 beginning at the top of the subfloor, I'll draw a line here and move it every 7 9/16 and times that by 14. It would look like this. So each stair would be equally spaced from top to bottom. We'll now take this measurement and apply it to the stair stringer. The vertical part of the stair stringer that we just talked about is the stair riser. The next part is called the stair tread, and the math on that is simple because it will always be 10 inches long. These stair treads are a certain distance, and we are always going to use 10 inches for the tread, and the part that changes every staircase will be that vertical measurement that gets divided to something under 8 inches. Okay, that's it for this video. Be sure to watch the next video where we'll go over transferring these steps and math to the stair stringers and drawing them and cutting them and putting all the pieces together. Thanks for watching.